rich functionality. High availability. There is, in fact, no single point of failure in this system. Each system adds its own, how do you say it, has its own management, and you don't have a single system where you depend. It's self-healing. For instance, imagine that you have a replica Gluster environment, and one of those replicas, let's imagine this too, goes down for whatever reason. If you repair that system, and if it comes back, it will start self-healing. You don't need to do anything. It will rebuild automatically. And your data is stored away in a native format. So we don't write data away in some strange format or whatever. It's just on the XFS file system. If something would go wrong on whatever reason, you can always access the data on that storage server by going to the brick volume. Normally you shouldn't do that, but in case of emergency, you can always access your data. It's not encrypted or something like that. For instance, if you want encryption, you can enable that. That's possible, but it's stored on a normal file system, so no strange things here. You can use this for business continuity and disaster recovery, especially when you use a geo-replication, which means you use asynchronous replication to some other site, meaning you can replicate from data centers to public clouds. You're not stuck to one single use case. No hotspots, because files are spread throughout this file system, which eventually means on even which brick. And we use a single global namespace. We have discussed it many times before. A single mount point. You can span your data over public, private, on premises, on different locations. And if you had plans to move to the cloud, then this is also a good solution to move your data from local into the cloud or replicate it into the. Then the compatible hardware vendors, like we said, HP for instance, Dell, IBM, Cisco, Fujitsu, NEC. Those are the brands which are supported at the moment, and a list which is growing all the time. If you have any doubts, you can always check out the Red Hat website, where at RHEL there is a list of hardware compatible RHEL. Then we are, in the end we are at the technical session, so how is this installed? We put the DVD, I didn't choose to do a live installation here because I have only virtual machines, which takes probably extra time. I made some screenshots, we'll get to that later and I'll show you how it works. So the installation, the only thing you have to do is put in a root password and choose your file system. You can just click replace existing file systems, even if there is no file system. And then just click next. The installer will start. This looks familiar when you are familiar with the Red Hat installation. And after a few minutes, the installation is completed. And congratulations, your storage is complete. After that, when the system reboots, then you have to put in a host name, you have to enter your TCP parameters and configure a network time protocol client. Those are the only requirements you have to do afterwards. And when the system is up and running, when you have done all these things, then you can create actually a volume. The storage will always need LVM, which is mandatory, so always use this in order to get you support if something is going wrong. And it also enables you with a lot of flexibility. Format the logical volume file system using XFS, and then you have to use a special parameter. Min-I size is 512, which is used for extra information in the extents for Gluster. Like I said, always use LVM, which is mandatory. And then you have just a few basic commands. You don't have to learn a lot of commands to work with this. All commands start with Gluster. And when you have when you have a few nodes, then the first command is gluster, peer, probe, and then the host name. And if you have done that, then those servers are matched with each other. And then you have created a trusted storage pool, as they call it. So, for instance, you have two servers, you have both configured them, installed the software on it, and then just on one server, you execute the command gluster, peer, probe, and then the host name of the other server, and then you have a match, a trusted storage pool. And if you have done that, you can check if all worked out okay by putting in gluster peer status, and then you will see if it is okay or not. I'll show that later in this demo. When you have done that, when you have pierced these servers into a trusted storage pool, then you can create actually the volume, which goes by gluster volume create, and then you give the name of the volume and the type of the volume, which by default is distributed, which can be optional replicated or striped. So, gluster volume create example, type replicated, replica numbers 2, node 1, nodes 2. So that's just that's all you need to know to create a volume. And after the volume has been created, then you need to start the volume in order to make it available. And that's the only thing that needs to be done. Well, then I can show you some demo of how this is done. I have two virtual systems. And this is always handy with some presentation, and you have to switch back to. Keep my fingers crossed. Okay. Okay, we use QM and KVM here. I have prepared these machines. What has been done here is the standard installation. Just like you saw on the screen a little minute ago. And we have two systems here. I will also start this one. And this machine, this is just a RHEL 6.2 server, but could also be 6.3 or it doesn't matter. When we look at this display, you see a prompt cluster. We have just a normal prompt, and every command you do, you put gluster in front. So for instance, I could say gluster peer status. It says no peers present because nothing has been done yet. But you can also type in gluster and just enter, and then you get this gluster prompt. And after that you can just put in the commands that you... That's really quite simple. Let's have a look at what we have here. At this moment I have created a directory called bricks, and within this bricks directory I have created 3 bricks, like brick 01A, 02A. On the other server we have the B versions of that. These are all logical volumes. So volume group 01, logical volume 1, etc. We have 3 different volume groups, just to make it a little more clear. And what we are going to do now is create volume. Cluster, peer, probe, RHSS02, that's the host name of the other server. And it says probe successful. That's all I have to do. When I say peer status now.
How does security between 2 nodes work?
Sorry?
How does security between 2 nodes work? How can I, if I add myself to the peers, I'm added too, I think.
You have to install the system image. You have to be in the same network, and then you can.
Yeah, but if I do not want others to just add them, although they're in the same network, how do I not have that happening?
Yeah, you should block that off by using firewall or things like that.
Okay,
There is no authentication or security yet. If you are on this network and you have access to the prompt, you need to be root user, and then you can probe, and if you probe, you add yourself to the trusted storage pool. But you have to be root first, and you have to get access to it. But there is no further security on that. Yes, but
it was for since version 1, or when it even was installed.
Sorry?
Basic node denial allows for IP based. Basic security has been in GlusterFS since it was invented by the Indians back in 1990 something.
Yeah, but you have to configure that.
And there is actually basic security in Gluster.
There is.
Okay. Well, we have PHP service, and now I can ask the appear status, and it tells me that hostname RHSS02 has been added. And if I do the same on the other server, you will notice that it suddenly has appeared. At this moment we are looking at the IP address and not the hostname, and this is something that occurs rarely. I think that has something to do with the virtual environment and DNS, things like that. So what we're going to do next is create a basic volume. Gluster volume create. I'm just doing this to show you actually how simple the interface is. And this is the name of the volume, distributed one. And after that we specify the service where the bricks which we want to use into this volume. So I have to put in the host name. I have a directory bricks where my bricks reside. This is the first brick. And now we have to add the next one. Okay, so what we're doing here is create a distributed volume by using brick 1A and brick 1B on both servers. I press enter and it says that the volume has been created successfully. The next thing that you should do, volume start and then the name of the volume. And now the volume has been started.
Don't specify your size parameter?
No, that has already been done in the bricks, because you create a file system on your bricks of a certain amount. Yeah, and then you combine these bricks together into a volume, and then you can have a look at what has happened, volume info, and then it tells you what is present on this system at the moment. And there we see that we now have a distributed volume, which is started, which has actually two bricks, which is using TCP as the connection protocol, and those are the bricks which are used. This is the command line interface. There is also coming up a graphical interface based on overt. Unfortunately, I cannot show this because I don't have enough resources on my system to make that work. But there are some. Eventually, I have a little movie of that how it works, and it actually does exactly the same. But then you click in the graphical environment, and beneath it issues these commands. So we now have a distributed volume. With volume info, we get above info. When you just want to see which volumes are there, then I can also put in volume list, and it gives back it's one volume distributed one. So you should be careful in choosing the name so that you know what is beneath. If I now switch over to the other server, server 2, and I put in the gluster command here, and I say volume info, then you see I have done nothing on that machine, but it gives back exactly the same information. I can also issue the same commands there and manage this Gluster environment from there, and from every other server which will be add on later. Okay.
Is there a tab completion?
No, not at the moment.
Can build it yourself.
I don't think so. Yeah, it is. Sorry, it is. Okay, volume create. We now create a replicated volume, replicated 01, and now I have to specify this is a replica. And I also have to tell him how many replicas, in this case 2, because I have 2 servers. And now the same old story. Bricks. You really, if you do this by the GUI, you don't have to think a lot about. But now you have to be careful what to type in. Operation field. Okay, so I've done something wrong here. Volume create.
Bricks. Yes, is best in second list.
Sorry?
Aan het einde ontbreekt de S, wordt dan niks. Slash.
Tik moet bij B.
Okay,
Ja.
thank you.
Heel erg.
Okay, now I have a slight problem because it has marked just one already as a. So let's do the exercise again.
Okay.
And I just use break 3. Okay, so here we have the information about the volumes. We now have a distributed and a replicated volume. Of course, we see the same information on the other side. Then I also have a Windows system. I have to put in the welcome. If I open a file browser here, and then I can browse to just one of the nodes, and then you see your distributed and also replicated volume. And I can put data in there, of course, and read from it. When we are looking at a Linux host,
This means that that storage server automatically shares it through someone
Exactly.
because you need to do some extra work if you do it manually.
it's automatically access to SMB share, but as a matter of fact, by default, it's disabled. The service is not running, but it creates the share for you. It appends it to the smb.conf, and if you have the service running, then it will become available in Windows. In these systems, I have switched SMB service on just to show that the shares are available in Windows. And on the
If you want to create a replicated striped volume, do you actually create the striped volume on top of the replicated volume, or is it another combination?
no, you just create it at once. So you at the command line you specify what you want to have. Distributed is default. So if you want to have a stripe replicated, then you can put it in at the command line. Volume create, stripe, replicate, etc. Of course. Okay, what I want to show you next is how we mount the volume on a Reddit system. What we're typing in here is mount min type GlusterFS, which means it will use the fuse protocol. And then I just specify one of the host names. It doesn't matter which one. It automatically routes to all the other servers in the cluster. So you don't have to specify all. You just point to one server, and Gluster layer is taking care of the routing behind.
That's only for the
Exactly, because if you use NFS or CIFS, then it's a different thing. Then you are connecting to just one of the servers in that server. There on the cluster layer, it's rerouted again. And that was in one of the first slides that you have this algorithm on the client, the native client, but not on the other clients. But if you want to have some kind of redundancy, then you can always use CTDB in combination with CIFS or NFS in order to have a sort of load balancer round robin over the different access points of data. Let's say distributed.
You specify the volume name.
Yeah, the volume name. You specify the volume name, and let's say we put it to. I've prepared this to this directory. Just press enter and wait until shit happens. And now you see that we have mounted RHSS1 distributed 01. And when I say mount, then you will notice that we are using the type fuse GlusterFS.
How do you make sure that you have a failover on that mount point? Because that's if that host goes down, you don't have a mount anymore.
No, that's correct. That's correct. But
So the whole high availability side to it is
the client is aware of that. The client, you just for the connection, you use one of the servers. It doesn't matter which one, just one of them, and the client is aware what is lying behind because it uses this Gluster protocol.
It switches if one goes down.
Yeah, it's another thing, and that was the question of this other server. When you use CIFS or when you use NFS, then you have a single point of failure, but you can enable CIFS and NFS on all nodes, so serve them out on every node, but then there is no redundancy in the connection, because if that node goes down, your client wouldn't know that that happened, and you have to manually connect to another, or use the CTDB application in order to have some load balancing or redundancy.
What's the performance of the GlusterFS mount? Well, because I've read that the NFS mount on top of a GlusterFS is supposedly to add to the performance to it, and if you say it's a single point of failure, you might not do it.
Yeah. I really don't know. I wouldn't dare to say. I have to look that up.
I see it's using Fuse, so that's user level, user level file system support. So it's probably a little bit slower than NFS.
Yeah. But on the other end, it gives redundancy. But
if you have a native client and a volume in a replicated mode, and you try to open a file descriptor, but one of the replica is unavailable, what happens?
nothing. You just get the file served. But the file will stay available if you have a replica and one goes down. Therefore, it's a replica, so you don't get error messages or something.
But if I open a file for writing, and it can only write to one of the replica?
No, it writes to both systems at the same time.
What if one of them is unavailable?
Then it would write on just the one who is available.
So then you have the replica out of sync.
Yes. And if that, I mentioned it before, if this replica which is killed or whatever or has died and you bring it back, let's say there's a hardware reason and you repair it and bring it back online, then it will immediately start a self-healing mechanism and resync the data, but the end user won't notice because it talks through this Gluster layer, which is actually aware of that. So I've tried this out with a demo setup and just killed the system, and it keeps. Okay.
So you would stop RHSS1, it will still be served.
Yes. Yeah.
Can you also allocate resources to the resyncing process?
So it won't eat up all your I/O, for example.
I'm not sure. Probably you can, because it's just RHEL beneath. So actually, but not in the Gluster console or things like that. You can do it there, but you have a lot of options, but no throttling or things like that. But you should be able to do it in the operating environment below, which is actually just RHEL.
Does it really detect performance difference between nodes? One is on slow disks, one on fast disk.
Yeah, I think so.
You have a lot of I/O on one. Does it switch to the other one?
The Gluster layer, so the fuse thing, this is actually doing some load balancing or redividing resources. But I wouldn't dare to say if you've noticed that somehow. If you have slower disk on the first one and fast disk on the other, then for sure I think the slowest one would win.
Why do any caching? If you, for example, would run any instances from OpenStack on it, on a shared environment, what would be the speed of your instances then?
It's not at this moment.
Yes, but if I would mount a cluster from a node that is separate from my compute node, then it would end up being a bit different, I think. So it would speed a little bit there.
Yeah, I don't think there is any caching at this moment, but which is on the request list and probably will be added in later. But at this moment there is no caching mechanism other than this Fuse client, which does a sort of calculate and do things like that. But the caching in the form of that it caches files, that is not actually at this moment available.
The protocol, does it go upwards as well? In the sense of if I end up with a new version of Hat Enterprise storage, will I be able to start using the new version, and I will have maybe I can add the new ones later.
You have certain updates which are by RHEL, but you are stick to certain versions because it also uses this long-term support. For instance, if I take the Fuse client of GlusterFS, the community version, there is a chance that it won't work with the RHS version. So I don't know if that answers your question.
No, because I didn't quite understand your answer actually. What I was asking is if I have Red Hat 6.2 now, I go to 7 later, it increases the protocol version of Gluster, will I be able to use both at the same time, because I won't be able to update everything at once?
I don't think so. The last thing, you have to update everything at once, and it has to do everything with this long-term support. At the moment it's only supported in RHEL 6, 6.1, 6.2, 6.3. So I can't look into the future, but I think it would be, it should be there, but I can't say at this moment. Because it's just all new and it started off in June, so we actually didn't have updates so far. So I think it should be in there, but I can't say it for sure at this moment.